So here I just want to finish up the parent functions. The next one we have is our reciprocal function. Sometimes they call this the inverse function. But there are a few interesting characteristics, or important characteristics anyway. Let's look at the domain first, all right? So remember, with the domain, there's basically only two rules. You're not allowed to you're not allowed to square root a negative number because those are undefined. And then the second rule is you're not allowed to have a zero in the denominator. So you're not allowed to divide by zero. If we did have a zero here, it'd be 1 over 0, and that would be undefined. It blows up. We don't know exactly if it goes to infinity or where it goes. But those are the only two rules, really. You can't have a square root that's negative, and you can't have a zero in the denominator, so you want to avoid those things. So basically, what this means for our domain is that we're allowed to put any number here for x except 0. So we could say all real numbers except 0. All right. The other way to write that is kind of a complicated format, but it means negative infinity up to 0, but not including 0. That's the parentheses. Union with 0 to infinity. All right. So this means all numbers except for 0. Now the range does the same thing. The range, it comes from negative infinity, and it tries to get to 0 this way, but it never gets there. And then on the right half, it tries to get to 0 from here, but then it goes upwards towards infinity this way. So the range would be the same thing. It's negative infinity to 0, and then from 0 to infinity. All right. I do want to mention something here while we're talking about the reciprocal function. They have a special name for that thing where they're not able to cross it. So it's got this imaginary line, this vertical line here. That is called an asymptote. All right. It's a line that the function approaches. It's trying to get there, but it never crosses it. That's called an asymptote. So this one has a vertical asymptote there on the y-axis, but if we said that it would try to get to 0 this way for the range, but it never crosses it. That's its horizontal asymptote. This is one of the few functions that that have asymptotes. Okay. Next up, you get your absolute value function. It just takes whatever you give it, and it makes sure that it's positive. This one is just like the quadratic function. The domain, it goes left and right forever. So negative infinity to infinity. And the range, 0 to infinity. There's no negative numbers there, obviously, because you can't take the absolute value of something and get something negative, all right? The cubic function, let's see here. Now the cubic function is a lot like the linear function. Remember, the linear function just did this little number. It's really similar to that one. The domain, it goes left and right forever, really slowly. It goes down to the left forever and up and to the right forever. And the range is also negative infinity to infinity because it goes down forever and up forever. Now remember, the other reason why the domain is negative infinity to infinity is because you are allowed to plug in any number for x there. There's every number out there. You're allowed to multiply it by itself 3 times. All right, that's what that means.